Okay, so we're putting some example problems here with light and color. But before we do that, I want to ponder you a question here. So fire trucks are traditionally red. As you see in Chicago, fire trucks are red. But there's a bigger push to make fire trucks more like yellow, lime, green. You're seeing this more and more in different cities making this change to a lime green color. You see it more often than not also at airports that fire trucks are lime green. And my question for you is, why do you think that is? So what color makes more sense? Should we go keep red, or should we move our fire trucks towards a lime green color? So I'm gonna let you ponder that question, and we're gonna come back and revisit it at the end of our example problems. So keep that in mind. I want you to think about that as well. All right, so let's do some example problems here. So based on the following scenarios, we want to determine what color the object would appear to us. So a car is coated with a paint that reflects red light. So here's the key thing: it reflects red light. And remember that we talked about that objects appear the color they reflect. So if you have a car that reflects red light, it should appear red, because that red light is coming back into our eyes. So light comes in, it reflects back off the car, and that red light enters our eyes. So we can say that objects are every color that they are not. So a blue car is every color but blue, technically, because it has all the colors but blue in it. But we define color as the light that reflects into our eyes. So a wall reflects all colors. Well, if a wall reflects all colors, we know that all colors mixed together make white. So all the colors combined are white. Now a t-shirt is made with a fabric that reflects red and green light. Well, red and green light, that means we have red and green light coming back into our eyes, so red plus green is yellow. So our color is going to be yellow. So based on the following scenarios, determine the colors of the paper. Well, white light shines on the paper that observes blue. Well, let's see. White light is red, green, and blue. And this is all paper, and it takes in blue. So it's red, green, and blue. If red, green, blue come in, but blue gets absorbed, so only red and green come out. Eyes can see that red and green light, and red and green added together make yellow. White light shines on the paper that observes red, green, and blue. So once again, we have a white light, which is red, green, and blue coming in. And it takes in everything, so nothing comes out. Well, the absence of light is black. So white light shines on a paper that absorbs red. So once again, white light is red, green, and blue. This is all paper. We're coming in. It's a little hard to draw on the tablet here. Red, green, and blue. Well, if it takes out red, so what's left over is green and blue. Well, green and blue, green plus blue equals cyan. And then white light shines on a piece of paper that observes no colors. So if you have red, green, and blue coming in, this is all paper again. You have red, green, and blue coming out. Well, our eyes take red, the light, the green light, and the blue light, add together, and that is white. So white light is made of all colors, but red, green, blue, the primary colors, also combine to make white light. So yellow light shines on a piece of paper that absorbs green light. What color does the paper appear? Well, yellow is a secondary color. And so secondary colors of yellow is made of red and green, because red and green make yellow, so you have red light and green light. And if it takes in green, the only thing coming out then is red. So green doesn't come in, doesn't come out. So if red is the only light coming out that reflects into our eyes, then the object has to appear red, or the paper has to appear red. So red and, once again, yellow is made up of red and green light, because red and green make yellow. If it takes in green, red is the only thing that reflects off, so it appears red. Okay, so white light shines on a piece of paper that absorbs green light. What color does the light appear? Well, the paper appears. We know that red light is red, green, and blue. Well, if you have red, green, and blue coming in, but it takes away blue, all that's left is red and green. Red plus green, we said, is yellow. Oh, I apologize. Here, see, we're taking away green light, not blue. So we gotta go back and fix this. So white light, red, green, blue, comes in, and you have red, green, blue. So it takes away green. So what's left is red and blue. And red and blue add together make magenta, which is our secondary color when you mix red and blue. Alright, so coming back to our original question here, what color makes sense? Well, this is actually an interesting thing from a psychology and a physics viewpoint. The color that makes most sense is actually the lime green. Why is that? Well, green light, the yellow-green spectrum, is actually the easiest light to see from farther away. Human eye is super sensitive to red and green light. During the day and during at night, those are the light that we see the most. So actually, red is actually one of the worst colors to see at night. It's harder to see red at night than it is green, because our eyes are more sensitive to yellow and green. So it makes more sense, if you want your fire truck to be more visible from a longer distance, to use a lime green or yellow. Destroyed taxis are actually yellow, so you can see them farther away. Why construction cause yellow. So a lime green would actually be the most effective color to use at night, because it stands against black the most. In fact, you can actually see a green light farther away than a red light. We use red, yellow, and green, because red and green make yellow, but although red is harder to see at night, red actually stands the most out of green. So we have a red object and a green background. Red is going to stand out the most. So we still use red for traffic lights because red and green stand out against each other. It's easier to see the contrasts. But in terms of seeing colors at night, or even during the day, a lime green is easier to see to the human eye than red, which is why more fire departments are moving towards a lime green fire truck, and why a lot of airports use lime green fire trucks, so it's easier for the pilots to see the trucks from above. Alright, I hope you learned something. Thank you very much for watching, and I will see you next week when we talk about electricity and magnetism.